Number 229. How many of the integers that satisfy some inequality, how many of them are less than 5, right? So how many of them are less than 5? Well, the inequality that we're given is basically this. Well, x plus 3, and then first we have x plus 2. And this is greater than or equal to 0 when it's divided by x minus 2. So this equation is greater than or equal to 0. And when are the x values less than 5? Well, you know from the numerator that x equals minus 2 and x equals minus 3. These are okay. Alright, so these values are okay, and actually they fit under 5. So you already have 2 of the answers. Since this is an above 0 or below 0 question, and you know the top, they're both the same sign, plus positive and positive, generally speaking, then this pretty much dictates whether it's positive or negative. So when x is 2, then you're just getting to 0. Anything below 2, you're going to get a negative value. Anything above 2 will give you a result that's greater than 0. So x has to be greater than 2, right? So between 2 and 5, how many integers? Well, we have basically 3 and 4. So these are 2 integers plus these 2 that we got, minus 2 and minus 3. That's total of 4. So the answer is here, D4. So again, you have 2 in this direction, and then you have 2 in this direction. So these two combined give you a total of 4. So 4 is your total answer. Now let's take a look at what's going on here. In terms of concepts, you basically have an inequality, and you have to figure out, oh, well, when is it greater than or equal to 0? Well, the easy one is just to set it equal to 0, and then you quickly find out that x as negative 2 and negative 3 both work. So you know the answer is at least 2. 2 of them are less than 5, right? Negative 2 is less than 5, negative 3 is less than 5, so it's got to be either C, D, or E. Now between these three, you have to figure out, well, what are the patterns in terms of positive and negative, right? So you look at that denominator. When x is 2, you basically get dividing by 0. Alright, so that's basically the cutoff point, the inflection point. Anything less than 2, say it's 1 minus 2, that's a negative number. This expression will turn out to be below 0. It's going to be negative. So anything above 2, let's say it's 3, then you'll get 3 minus 2, that's 1. So then, basically that's going to give you a positive expression. So you know that x has to be greater than 2 in this direction in order to give you a final result that's greater than 0. So in that case, then well, 2 is no good by itself, right? The exact integer of 2 doesn't work, because then you'll be dividing by 0, and you can't do that. So 2 does not work, right? The 2 exactly does not work. So this is no good. But the integers 3 and 4 do work, because they're still less than 5 and they're greater than 2. So by following this inequality here, you identify there's two integers here, and then you already manually found that there's 2 negative integers that actually work, and these two combined give you a 4. And that's how you get the answer D as your final answer. And if you're not sure, let's say you're like, oh, well, minus 2, minus 3, what about minus 1? Would that have worked? Well, if you had minus 1, this would be a positive number, right? 2 minus 1. And if this were minus 1, it would be minus 1 plus 3. So that's positive 2. In both cases, you're getting a positive number, but then you end up dividing by a negative number, right? Minus 1 minus 2, that gives you a division by negative 3. So that brings you below 0. So this if you tested negative 1, that would not work. So minus 2 does work, minus 3 does work, only because it brings you to 0. But minus 1 does not work. And say you had minus 4. Well, minus 4, that would give you a negative 2 times minus 1. So negative times negative, that gives you positive, divided by, but then again, you're dividing by a large negative number, which is minus 4 minus 2, that gives you negative 6. So you're dividing by a negative number, so that brings you below 0. So either way, you're always going to be negative if you use another number that's minus 4 or minus 1. Only negative 2 works and negative 3 works because that brings you to 0. And then anything greater than 2 works because then you would be dividing by a positive number in both top and bottom, and that would give you a number that's positive. So these are the two negative numbers that work, and these are the two positive numbers that work that are less than 5. And so that's why you get a total of 4. So as a recap, we're basically given this expression, right? You have some kind of inequality divided by some kind of inequality, and it's greater than or equal to 0. Once you see this greater than or equal to 0, then you have to pay attention to signs, right? Always pay attention to signs. Are you multiplying a positive by positive and then dividing by a negative? That gives you negative. That's no good. Or are you multiplying by negative times a negative and then dividing by a negative? Well, the top gives you a positive number, but you're still dividing by a negative number. That gets you negative as well. So you got to pay attention to the signs. And then for the values of x that are good, how many of them are less than 5, right? So this is another requirement that they added this in. It turns out this top part allowed us to get the value of x equal to negative 2, and this one gave us the value that x equals minus 3, and we said these are good. And then this one, the bottom part was basically an x minus 2, so that helped us find that when x is greater than 2, that's okay. So combining this requirement with this requirement, you basically have, when is it when x is between 2 and 5? And it turns out only two integers work, 3 and 4. So two integers from here plus these two integers, that gets you 4 as your final answer, right? So 4 as your final answer.